Okay. So we're trying to figure out the spring constant, and we're trying to figure out the period. So this is 51. We'll do A first, obviously. Okay. So first thing to do is to kind of just show you what's going on, because I think it's kind of a little tricky sometimes. So we've got a spring that is just sitting here holding some scale. There we go. That's killer. And then we put some oranges in it, and it stretches it out. There we go. There's some oranges. Okay? And it stretches it out by 0.03 meters. That's how much it gets stretched by. 0.03 meters. Okay, so first things first, knowns and unknowns. Give you a minute here. See if you can figure out what the knowns and unknowns are for this one. So the mass is 2 kilograms. Okay, we also know the distance that it's stretched. I'm going to make it negative 0.03, and that's because it's stretched down. I usually think of stretching down as negative. And then K is what I'm solving for. K, by the way, is spring constant, in case you forgot that. Okay, so I'm thinking to myself, all right, I need spring constant, and there's two equations that have spring constant in them. The F equals negative KD, and the period is equal to 2 pi squared of M over K. Well, in order to use this one to solve for K, you would need to know what the period is, which we don't. So this one's out of the question. Also, a hint, I'm not going to make you use that equation to solve for K because it's too hard mathematically. Just so if you're solving for K, that leaves only one other equation. It's this one, Fs equals negative Kd. Okay, so far so good. Negative K, D is negative 0.03. Those negatives cancel each other. Okay, so far so good. But what I put for F, it can't be 2, because 2's not a force, 2's a mass. So something has to be F. I don't know what it is. 9.8. Good guess. You're close. Right? So 9.8 times the 2. And here's why. Well, I'll ask you, Braden. Why am I using that?
Because it's the force of gravity.
Well, why do I need gravity? Yeah, the gravity is the reason it stretches out. The reason it stretches out is because of gravity. Gravity is what pulls this down. So therefore, I can basically say the spring force equals the gravity force. So instead of Fs, I'm really using mg. And you can find that separately if you want, or you can just plug it in like I am. So the mass is 2, g is 9.8. The negatives canceled, so I just got K times 0.03. All you got to do is divide the 0.03 over. Solve that, see what you get for K. You should get 653.3. Okay. All right. So let's look at B. B wants to know what the period is. Well, that's easy enough. You just use the other equation. Period is equal to 2 pi square root of m over k. So just plug everything in. Okay, so see if you can do that. Plug everything in, see what you get. Plug everything in, get an answer for T, and I'll let you know if it's right or not. Say again. So it should not make a difference. I used the pi button when I made the equations, but yours will be slightly different. But it should. I try not to make answer choices that are like ludicrously close to each other. So like if the answer is like 6.5, I try not to have 6.2 as the answer. So like if you got 6.2 and the answer is 6.5, you can be pretty confident that it's just a rounding thing.
I know that sometimes I go on other tests, but it's like, I don't think it's like, you have like 6.5, so I'll just be like, oh, what's that? If I got pretty close.
Yeah, it's usually just rounding. Oh, you're almost there. So you did this part today. You forgot to multiply by this.
Oh, okay.
So you just didn't finish it. Yeah, you're on the right track. Anyone else questions? Yeah. I think I got like 0.3. I forget exactly what I got. Yeah, I got 0.3, 0.35. So, yeah. So when I plug these in, 2 pi times the square root of m, which is 2, over k, 653.3. And I got 0.35 seconds. So I did 2 divided by 653.3. I square rooted that answer. And then I multiplied that by 2 pi.
Oh, I didn't do that.
Yeah. It's easy to forget.
Oh my god.
All right, any other questions on 51? All right, let's see if we can squeeze one more in here.